IEC Industrial Control Schematics. Control panels. What is an industrial control panel? An industrial control panel may contain power or control circuits, or both. Its job is to regulate electrical signals and the flow of electric power. Industrial control panels can be found in small and large-scale systems. Numerous systems are regulated by industrial control panels and associated equipment, including infrastructure, manufacturing, food processing, agricultural, building automation, and hospitality. The main parts of an industrial control panel. The enclosure. The enclosure houses electrical components which protects them from the outside environment and from accidental contact. The enclosure must be rated for the environment that it is installed in. It also must allow proper heat dissipation. Note the vents in the enclosure on the left. Some panels may require air conditioners to control their temperature. In some extreme cold conditions, a heater may be required. The panel enclosures shown are manufactured from stainless steel. They are installed in a milk processing plant. Stainless steel enclosures are typically used in food processing. The back panel. The back panel is mounted into the enclosure. Its job is to provide a mounting surface for the electrical power and control devices. Mounting rails are installed to allow devices to be easily secured and positioned. These rails are called DIN rails. The rails shown are perforated or slotted. Rails without slots and in various sizes are available. Professionals cut rail with a specialized rail cutting tool. They can also be cut with a metal cutting saw. Also, wiring duct with removable covers are installed on the backplane to allow wiring of devices and neat routing of wires. Shown is an enclosure with the back panel installed. The rail, duct, and devices are mounted and are ready to wire. Large backplate layouts are drawn in CAD programs. They show all of the installed equipment, including the wiring ducts. Layouts can be plotted to scale or used as a reference drawing for panel builders. Equipment can be mounted, and most of the wiring can be done before the back panel is mounted into the enclosure. Panel disconnect, operators, and indicators. Industrial control panels must have a means of disconnection from hazardous voltage potential. These devices are called isolation or disconnect switches. These switches can be locked in the off position. This prevents accidental energization of the panel. Isolation switches come in various configurations and ratings. They can be either side-mounted or front-mounted. The unit shown is a front-mounted rotary disconnect with an adjustable length rod. This rod allows it to be custom fit to different backplane depths. Disconnect switches that incorporate fuses are often used. The unit shown is a 200 amp rated front mount device. Industrial control panels often have operators such as push buttons and selector switches mounted on the enclosure door. Also, indication lights or pilot lights can be placed on the enclosure door. The series of panel buttons and pilot lights shown are used to control and indicate the running status of a motor. The MOA selector switch selects between manual, off, and automatic operation of the motor. The green button starts the motor, and the green light indicates that the motor is running. The red button stops the motor, and the red light indicates that the motor is off. If the motor has been overloaded to the point that it caused the overload related trip, the yellow light will be on. Devices such as temperature controllers and variable speed drive keypads may also be mounted on control panels. These devices allow quick analysis and adjustment of controlled processes. If a control panel contains a PLC, often a human-machine interface or HMI is installed on the panel door, or remote to the main panel and a separate operator panel. Internal power and control components. Control panels can contain various types of control and power components. The type of components depends on what job the panel is doing. I will list components used in the panel and backplate layout shown. The system controls 3 fan motors, a feeder, a conveyor, and 3 heaters. The system utilizes a PLC with a small HMI. The system also contains a safety relay controller that monitors multiple emergency stop buttons. So I have a motor control and heater control panel. I'll go over some of the components typically seen in the panel. We will be covering this more in depth as we work through the program, as this is part of our learning resource document and schematic set. First things first, around the outside we have our ducting or cable ducting. And you'll notice that we have different compartments with duct above, in this case above what's called the PLC and below the PLC. All right, so we have our ducting. There are 2 rows of duct in the location of my mouse. The row above we use for the 24 volt power for control above, and the duct below is used for power wiring for all of these breakers and fuses. I'll scroll down and you notice the same down at the bottom for terminal blocks. You have a DIN rail and then terminal blocks mounted. There are multiple terminal blocks to group each area of power and control so that it makes sense when you're reading a diagram and you can quickly find where those connections are. All right, so we have a terminal block on the left here. It's our field power connection. So power comes in and then it feeds this fuse disconnect up above. Power is then distributed to the different power consuming devices. We have 4 motor DOL motor starters, K1, K2, K3, and K4. They are motor starters and they have overloads connected to each one. They are all drawn, they're all shown in the drawing. Over on the right, we have an inverter, otherwise known as a variable frequency drive. Up above the DOL motor starters, we have some 3-pole circuit breakers, Q1, Q2, Q3, Q4, and they protect all of the circuit conductors for these DOL starters. Right beside Q4 is a 2-pole circuit breaker. It supplies power for a 24 volt DC power supply up here. We'll come back to that in a minute. There are 3 2-pole fuse holders. These are finger safe fuse holders. They supply power for heaters. And they work with these heating relays and a temperature controller that's mounted on the door that controls the heaters. There's one more component I want to go over here. It's Q6. That is the circuit breaker and the protector for the inverter or variable frequency drive. Okay, so up above, we have our power supply. This unit converts 230 volts AC to 24 volts DC. The 24 volts DC is supplied to all of the control devices. So the 24 volt DC is distributed through these fuses, F5, F6, and F7. It supplies power to the CPU for the PLC and the input and output cards, and also this e-stop monitor or e-stop controller on the far right side of the PLC. So the PLC is the brains behind the system. It controls a lot of aspects of the controller. In the case of the e-stop monitor, we operate these two safety contactors. They are interposing contactors or expansion relay contactors for controlling all of the field loads. To the right, there are 3 relays, R4, R5, R6. Those are interposing relays that interface between the PLC outputs and current consuming field devices. So let's just have a look at terminal blocks again. TB4, when we look at the drawings, TB4 is used to interface between the 24 volt control power, and all of the operators and indicator lights on the panel door and the DOL starters and heater circuits, the control portion of them. TB5 is used to connect all of the PLC devices and field devices. TB6 interfaces the e-stop controller, and TB7 interfaces the temperature controller sensor. Okay, so I'm going to just scroll down to the very bottom. Down at the bottom, we have power coming in, as I mentioned earlier. But TB2, the job of TB2 is to send power out to the DOL motor. So the motors that are controlled by K1, K2, and K3, K4 are all connected here. And also there are 3 heaters that connect to this terminal strip. So notice how all of the field power devices are grouped onto one terminal block. That is good design. Summary. The job of an industrial control panel is to regulate signals and regulate the flow of electric power to a control system. The main parts of an industrial control panel are the enclosure, the back panel, operator and indicator devices, PLC and HMI if equipped, internal power and control devices such as breakers, fuses, disconnects, DOL starters, relays, and safety controllers. DIN rail is used to mount most electrical components, and wiring duct is used to separate and neatly route power and control wiring.